Good morning, Chem 20s. Our lesson today is going to be the start of acids and bases. We are going to look at the basic properties. Most of this, I would assume, would be a review for many of you. All acidic compounds are acids in solution, but only some exist in pure forms. For example, solid salicylic acid, liquid acetic acid, and gaseous hydrogen sulfide. Other acids like carbonic acid and sulfurous acid only exist in aqueous solutions and decompose before the pure compound can be isolated. Chemically speaking, the acids are interesting species, but probably the best reason for studying acids is that a large number of common household substances are acidic. For example, lemons and tomatoes contain citric acid, and vinegar contains ethanoic or acetic acid. Many common household substances are also bases. Milk of magnesia contains the basic substance magnesium hydroxide, and household ammonia is a common basic cleaning agent. Bases can be ionic or molecular substances. So, in order to readily distinguish between acidic and basic solutions, we have used many different indicators up until this point. We have looked at litmus paper, whether it be red or blue litmus. And we've also looked at pH paper. This could be universal indicator paper, or even we've looked at pH meters. And that would be substances where if you possibly have, let's say, a hot tub at home or an aquarium at home, or maybe you're into gardening, you might have used some sort of water test or a soil test to figure out the acidity or basicity of your soil to see is there anything we need to add to grow, let's say, tomatoes compared to geraniums. Well, we're going to start pretty basic today. We have our pH scale, and the pH scale is always broken into three sections. We'll notice that it goes from 0 to 14, although it is possible to be higher than 14 and actually lower than 0. But the middle of our pH scale is at a pH of 7, and this is the spot where we call neutral. This a perfect example of something that's neutral would be distilled water or pure water. We tend to call both those the same thing. As we go below 7, that is when we're talking about an acidic substance. And things that are acidic from your house might be a pH of 2, lemons, a pH of 4, tomatoes. And again, the lower our number gets on the pH scale, the more acidic it's going to be. So a pH of 0 is more acidic than a pH of 2. A pH of 2 is more acidic than a pH of 5. Going back to neutral again at 7, as we go up on the pH scale, that is where we get more basic. Now, another word for basic that you might hear is alkaline. So, some substances from around your house that probably fall in the basic category would be pH of 12 would be soap, or a pH of 10, which would be a stomach tablet, if you think of a Tums or an Eno or a Pepto Bismol. Again, starting at just above 7, these are weaker bases. And as you get to a larger number on the pH scale, this is where we get to have stronger and stronger basic substances. Now, what I would like to do is let's take a look at our properties of acidic and basic substances. So, most of these we know from before in previous studies, but we're probably going to add some in there that you haven't thought about. This is a mixture of empirical and some theoretical properties of acids. So, property number one of acids, acids conduct electricity. You'll remember from previous chapters that we know that acids, when we use the conductivity tester, the light's going to turn on. All acids conduct electricity in solution. Acids also taste sour. Now, that is fine saying when we're in elementary school, because again, when we're in elementary, we're not probably not using any real acids from the lab. We're more or less talking about foods, lemons and limes and tomatoes and strawberries, those sorts of substances. However, in the lab, when we're talking about things like hydrochloric acid or phosphoric acid, tasting something is totally breaking against the lab rules, and that will not be tolerated. Acidic substances also have a pH less than 7. And it is important in this chapter that we understand the arrows and how to read them. So any pH lower than 7 will be considered acidic. Also, we're going to look and go a pH lower than 7 is acidic, but then when we test it with litmus paper, we know that red litmus stays red and blue litmus turns red. And I'm going to prove it to you. We've done this many times before, but I have an acid in the beaker. This is, I believe this is hydrochloric acid. And so what I'm going to do is I'm going to take some red litmus paper and I'm going to dip it into my acid. And we're going to see that red litmus paper stays red. Now that is going to be very different than when I take blue litmus paper and I dip it into an acid. And we'll notice that blue litmus paper turns red in an acid. Our fifth quality of an acidic substance is that acids are corrosive. Now, there are strengths of acids, and so we get stronger when we get closer to 1 and 0. But even up here at 4, 5, 6, acids are corrosive. When we think of acid rain actually is any any precipitation that falls from the sky that has a pH of 5.6 and lower. So if we think about it, these are also corrosive because remember, these guys can corrode statues or corrode or wreck plants, cause havoc on farmers' fields. So it's very important that we understand anything below 7 is acidic. Acids also react with metals like magnesium or zinc to form hydrogen gas. If you think about this as a single replacement reaction, and I'm just going to write one out here. So let's say we take magnesium. Oh, and I better get a pen color we can see. So I'm going to take lime green again. So if we take magnesium and we add it to, and I'm just going to pick an acid you know, hydrochloric acid, right? Cation, so they're going to exchange places. Hydrogen is always going to come off on its own. So that just proved that when you add a metal to an acid, we're going to make hydrogen gas. And then we're also going to make magnesium chloride. So again, we could balance this 2, 2. It's all good to go. But the important part is this here. When we react our acid with a active metal like magnesium, we will always produce hydrogen gas, which means we're going to see bubbles. So let's do this. Let's actually get rid of that. So it's not in our way anymore. Okay, and the last property of an acid is that acids neutralize bases. So Miss Countryman, when she handles our waste after the end of a lab, she will test our waste products with litmus paper. And if the litmus paper shows that it's a base, meaning our red litmus paper turns blue, or our pH is greater than 7, she will add a little bit of acid to it. And so she will add a little bit of vinegar because it's cheaper to add vinegar because you can buy a big jug for much cheaper than you could buy, let's say, hydrochloric acid or sulfuric acid. So acids also neutralize bases. Well, to do a comparison here side by side, now let's look at bases. So we are looking at alkaline substances. Well, a base also will conduct electricity. As we saw in previous studies, both acids and bases conduct electricity. Where acids taste sour, bases, on the other hand, are going to taste bitter. Some substances that would fall in the base category, because bitter is kind of hard to describe, would be something like celery or possibly radish. Okay. Um, pH of a base would be a pH greater than 7, so anything above 7. Again, stronger base would be up closer to the 13, 14. Weaker base would be down by the 8 and 9. Again, with litmus paper, red litmus paper turns blue in a base, and blue litmus paper stays blue in a base. So I have myself a base, and again, I'm going to test it. This time we're going to start with red litmus paper. And in my red litmus paper, I'm going to dip it in. And you will see that when I pull it out, it has turned blue to represent a base. But again, we like to test out both litmus papers so we have confirmation. So I'm going to take my blue litmus paper and I'm going to dip it in. And my blue litmus paper actually stays blue. Another property of a base is it's also corrosive. So when we're dealing with acids or bases, we want to be very careful with our hands. We want to make sure we're not spilling. We might even put on gloves when we're doing an experiment. Bases also feel slippery. If you think of some substances that are bases, cleaning supplies is the perfect example from your house. It could be, let's say, Mr. Clean that you might use to mop the floor in your kitchen. It could be Pledge, which you might use to do wood surfaces like banisters. If you've ever come home from school and you've kicked off your shoes and you've gone running into the kitchen all excited to have a snack, and you slid right past the refrigerator in, thump against the wall or the cupboards because you didn't realize that your mom, while you were gone at school that day, she has washed the floor. And when she's washed the floor is still not wet when you came home and slid across it, but the floor is slippery because a little bit of base is still on top as the surface got cleaned. A little bit of base is still on top. Same with if you've ever touched a banister after it's been wiped with Pledge, right? It's got that little slippery film almost on it. That is the base on there still. And the last property of a base is, well, it makes sense. If an acid neutralizes a base will neutralize an acid. So again, if we test waste products before we pour them down the sink, if they test as basic, we are going to add a little bit of acid. Now, again, um, when we test a substance and it's a little bit of acidic, we are going to add a base to it. And so a base we might add is baking soda. Again, it's less expensive than something like sodium hydroxide. And so we just sprinkle some baking soda in, it'll bubble. When we add baking soda and it stops bubbling now, there's no more reaction. We know that it'll be neutral, and now we can pour it down the sink safely. Okay, so we have looked at acidics, and we have looked at basic substances. The last thing I want to look at before we're done today is let's look at neutral. So on the pH scale, this means we are looking at substances with a pH of 7. What that really means is that our substances we're looking at has neither acid or base properties. It's dead in the middle. It's a nice equal balance of those of acidic properties and basic properties, and they tend to cancel things out. So this only occurs when we have a pH of 7, and you already know are a perfect example of this, and that would be distilled water. So I have some distilled water here, and what I want to do is I want to prove to you that in distilled water, red litmus paper will not move. It will stay red, and blue litmus paper will also not move, it will stay blue. So I have a piece of red litmus paper right here. And so I'm just going to get it with my tweezers. So red litmus paper stays red. And my blue litmus paper is going to stay blue for a neutral substance. Now, again, distilled water is not my only neutral substance. If you think back to previous studies, you saw that ionic solutions were neutral as well. They do not change in litmus paper. Molecular substances are neutral as well. They do not change in litmus paper. Well, the last thing I wanted to do before we left was I wanted you to see all the properties on our pH scale together. We're going to spend the rest of this chapter diving in, leaving this, starting with this basic point, which is like to refer to this as our baby steps. All of this has come from previous studies. And then we're going to take a giant leap and we're going to start looking at, well, what does this mean when we talk about concentrations of an acid? Does this have an effect when I'm looking at higher or lower concentrations of HCl? What does that mean when it comes to the strength of an acid or the strength of a base?